Assalamualaikum warahmatullahi wabarakatuh. We will explain about the Lab 3 Infinite Impulse Response IIR Filter Design. My lab partner Azimah binti Zainal Abidin and me Nur Aliza binti Mazam. Okay, next we go to the procedure. Okay, for part 1 is we have to do the coding for the pass band. And then the second part is the coding for the stop band, and then the third part is coding for IR low pass filter based on Butterworth design. On the IR filter low pass filter, we have the coding for the filter parameter, and then we have to mapping the angular frequency for Z domain to S domain, which T equal to 2. And then next we have to do the transition ratio coding, and then next we have to do the Butterworth filter determination. So we run the coding. Okay, so on the workspace here, we have to compare the value that we get from on the workspace from the MATLAB to the calculation that we have done on the exercise. So next we go to the part 2 coding. For the part 2 coding is the coding for the low pass IR filter design. Okay. For the first part is we have to do the coding for the pass band, and then the second part is the coding for the stop band, and then same which goes to part 1 where we have to do the IR low pass filter based on Butterworth design, and then we have to do the filter parameter, and then mapping the angular frequency for Z domain to S domain, which T equals to 2. And then we have to do the transition ratio, and then we have to do Butterworth filter all the determination, and then from that we have to do the coding for the Butterworth filter 3 dB cut-off angular frequency, and then butter filter analog with 3 dB cut-off angular frequency at 1 radian per second. And then we have to do the filter transfer function polynomial coding, and then we have to adjust the denominator. Then we do the bilinear transformation magnetic response, and then the last part we have to do the plot for the magnetic response for IR low pass filter. So we run the coding. Okay, from the coding, so the coding we have to plot the coding, right? So this is the result that we get from the coding, that it show the magnetic response H1 Butterworth. So the x-axis is the normalized frequency, and then the y-axis is the H1. Okay. Next we go to the coding for part 3. Okay, for part 3, we have to do the coding for low pass IR filter design, where it has the pass band, stop band, then we have to do the IR low pass filter based on Butterworth design. And then we have to plot the magnetic response on the IIR low pass filter. And then this is the MATLAB function for this coding, for the plot. And then we run the coding. Okay, so it shows the result for the magnetic H2 Butterworth MATLAB. This MATLAB on the figure 1. So the x-axis is the normalized frequency, and then the y-axis is the H2. Okay. Then from the MATLAB, it shows the calculation on the workspace. Next, I will pass to Azimah for the part 4.
Okay, thank you for Thank you to Nok Aliza meeting exam. Okay, for next part is high pass filter. We use high pass IR filter design. We use coding original and modified. Then this is coding for pass band, stop band, and then we need to do high pass filter based on butterworth and magnitude response. Next, we plot the magnitude response of IR low pass filter. Sorry, high pass filter. So we run the coding. As you can see here, this is a graph we get. Magnitude response #2 butterworth. So this is a #2 for y-axis and x-axis normalized frequency. Okay, this is a workspace calculation we get. Okay, next, bandpass filter coding. Okay, for bandpass filter coding, we use a pass band, stop band, bandpass filter based on butterworth, and then we plot the magnitude response of IR filter design. So we run the coding. Okay, as you can see here, this is a graph we get for magnitude response #2 butterworth. So this is a #2 and this is normalized frequency. So this is a graph of magnitude response. And then this workspace calculation at workspace we get. And then we plot the graph. Next, band stop filter. Okay, for band stop filter, we use a band stop filter. We use pass band and stop band. We just change the value 0.2, 0.8, and 0.3 and 0.7. So next we use band stop filter based on butterworth design using MATLAB function. Next we use a magnitude response, and which is n equal to 1024. Next we plot magnitude response band stop filter. We use a value 0, 1, -3, 4, 5, and 2. So this is a calculation for workspace we get, and this is a graph magnitude response #2 butterworth we get. #2 and normalized frequency. #2 versus normalized frequency. So we plot the value. Okay, for discussion and calculation, this is a calculation for question A. Transform the 3 dB cut off frequency of 0.2 and band stop frequency 0.3. So this is our calculation. For B, we need to determine and show in figure. So this is calculation for pass band for B and stop band. Okay, next we need to determine ratio K and parameter K1, and also design a butterworth filter that meet the filter requirement set for filter 1 as described earlier. So this is a calculation for C. So this is the answer, and this is a calculation for D. Okay, for E, we need to convert the transfer function derived in exercise into the Z domain using bilinear. So this is our calculation, and this is the answer. Okay, for discussion, based on the result, the student managed to see the value is almost the same between data and result when we verify it with the coding given and the output. Then the student built the butterworth IR low pass filter using bilinear and butter function in MATLAB. Furthermore, the student also built a butterworth IIR low pass filter using butter and butter function. The students are able to see that when using butter and butter, the value is much more accurate rather than bilinear and butter. Finally, the student managed to build a high pass filter, band pass, and band stop filter by change a bit coding given. So this is our conclusion. Okay, that's all from us. Thank you.